Welcome back to Lunch Logic. This is Luke.
This is Devin.
And this is Ben.
Today, we're going to talk about infinity. Let's talk about infinity, guys.
All right. I will start this off. So something very interesting about infinity is whether it actually exists. I think, is time infinite? Is space infinite? Are, a lot of these questions, people debate over them. But today, as the guest on the show, I am going to give an argument on why infinity does not exist in the real world. And although we use it in math, it does not exist in the real world.
I have a question.
For sure.
So, if we assume that math is in the real world, does that make infinity real? So,
Well, it's a big assumption.
Are we making a distinction between mathematics and the quote-unquote real world?
So I think we use math to show how the world works.
Sure.
Math is able to run our elevators and our cars and our things that we use in our daily lives.
Yeah.
But it's not necessarily the real world. Math is just used to show. This is my argument, in my opinion. It's just used to show how the real world works.
Yeah, I mean, I'm sure we could argue about the how real math is in the world, and we've definitely had an episode on that, or maybe a few. But yeah, for the sake of this particular episode, let's just assume that math and reality are somewhat separate.
All right.
So why don't we just call reality as the physical world so we don't confuse it?
Yeah.
Okay.
Good idea. Yeah.
Okay.
Right. Take it
So
away.
this is the argument. The argument is as follows. Infinity is only used in math. Let's look at time, for example. If you're going to talk about, how can something come from nothing, then you run into these inherent paradoxes where if nothing can't come from something, and that's simple enough, but if something has always existed, then therefore time has to go infinitely backwards. And that you start running into the problem of things become magical. Let me give a great example.
Okay.
Let's look at infinite universes, right? If we had infinite universes, then there's another universe where something is just slightly off. Or some you guys have heard of quantum entanglement, right? Where some there's particles can phase through objects. There is a universe where I have phased through every single livable planet. I phased into the sun. There is a technical universe, assuming there's infinite universes, where that works, and that just makes zero sense.
Well,
you start
why
running
not?
because you start running into issues where I think the human brain just can't comprehend. Imagine if I just say, and voila, I'm holding a chicken. There is a universe where literally everything that has happened right now has happened now, and an actual chicken spawned into my hand.
Sure, but
The odds of that are just infinity does not exist.
But doesn't that have to happen if there are an infinite
exactly
amount of universes?
right?
Yeah.
Which is why I don't believe there is. That is the exact argument.
So you're saying because the result is so ridiculous, we should abandon the pre-assumption in which that there should be an infinite amount of universes.
It's the idea of things start becoming magical, and that doesn't make sense.
Interesting.
well, it's not magical, is it? It's sure it's improbable to us, but given infinity, it's inevitable.
Exactly, which doesn't exist. That's the point.
Well,
it doesn't actually.
But you can't just say it doesn't exist without knowing. Well, is that an assumption that you want to have, or if we're saying, I thought we were assuming that there's infinite, universes.
Right.
Okay.
I'm assuming there is infinite universes, and right now I'm proving that nothing's infinite. Right. This whole argument
Sure.
is showing that time isn't infinite, space isn't infinite.
So
And the argument is things start to become improbable, not possible. Even more basic stuff I was talking with Luke before the podcast here about a circle, right? Pi is infinite, and that is obviously a mathematical concept, so it's not included, right? Let's look at in the real world, right? Well, technically there is no such thing as a perfect circle. So at some point in the real world, even when we use it mathematically, right? Pi has an ending point, at least for us. and like when we actually like use it, right?
Sure.
And so, for me, I guess it just makes sense that like there is no possible way that infinity could exist.
Okay, so, well, you bring up the idea of perfection and how in perfection there is infinity, right? Like, pi, digits of pi.
Sure.
And pi can only exist if there's a perfect circle.
Pi can exist in the mathematical world. Again, we're separating.
All right, so guys, are we assuming that? So we made a clear distinction between the mathematical world and the physical world. So now we're debating whether infinity is real in the physical world. But can we, like, is our pre-assumption that infinity is real in the mathematical world?
Yes,
okay.
it is completely real. We use limits all the time.
Okay.
We use
Just want to make sure.
Yep,
All right.
for sure.
Yep. Yeah, it's somewhat fundamental to math, but
I mean, maybe we could also talk about like the what is it called, the arrow,
The Zeno's paradox.
Zeno's paradox, which is the idea like if you look at it in a math concept, right? And then maybe this argument for you guys, right? Like technically the arrow never reaches.
It should never reach because you have to.
Should we explain it?
yeah,
Or-
go
Sure.
ahead and explain it.
So I guess like the theory or whatever, the experiment that he showed was if I shoot an arrow at a target and it goes halfway and then halfway again.
Yeah.
In each time the arrow will keep going halfway.
Yeah.
If you think about it like that, technically it'll just go right next to the target, like so close, but it'll never actually hit it.
Right.
But
Sure.
obviously if you shoot an arrow at a target, we know what happens.
Right. But, well, okay, so the reason why we have that kind of paradox is because I don't think we understand how the physical world works. So in physical world, everything is discrete. It seems continuous, but we have such, things like Planck's constant, like the smallest unit possible in the physical universe. Now, in the mathematical world, you can keep dividing it by 2 and will never reach 0. I mean, if you keep the limit, or if you get the limit to infinity, then
Only
it will...
if we use infinity, it works.
Right. But in the physical world, it has to come down to the smallest unit possible. It could never be smaller than like Planck's constant.
Sure.
You know what I mean? So I think that's kind of what's causing this paradox, perhaps.
That's a good point. Yeah, and it makes sense from Ben's perspective. Like, that's a key difference between physical and mathematical. But I kind of want to go back to your idea of multiverses. Infinite different universes existing separately, but with infinity comes, the idea that everything that could ever happen will happen, right? Even
No matter how ridiculous, no matter how impossible,
yeah.
it technically could.
But so why is that necessarily so?
Maybe possibly it's a literally a limit in the, like, for my mind, like literally a like barrier that like it's just not possible. Like you cannot, like, there are things that like you experience in the real world that's just makes sense.
Yeah.
And it just, like, my brain cannot comprehend it. It doesn't make sense. Like,
Sure,
how
that's fair.
many times would it take for me to say there's a chicken? How many times would I have to say that before an actual live chicken comes in? Not one that's like one feather, which is improbable to 0, basically.
Yeah.
But a whole one that's live and living, that's not messed up, right? Like the odds of that happening, and then have that one, and now we have a different one where now it's a different.
And then
object.
that one becomes president.
Right. No.
Something like that.
Like, it just doesn't make sense. You run into other issues too. Like, I think there's other paradoxes as well that we can talk about. Like, if you have an object and you cut it in half, and then you cut it in half again, you cut it in half again, cut it in half again. I think there's an end.
Oh, well, that's a little bit different, because if we had an instrument in the real world that could cut something in half an infinite amount of times.
But I think our modern science shows that there is an end to it. Like there's
Right, like
well,
elementary
the Planck's
particles.
constant, Sure,
Right.
sure.
Like there's
That's
no way you can cut that open again. Like even the most things that you would think to be infinite are just not. And
Wait, Ben, going back to the chicken example. So I know that it sounds ridiculous that such things could possibly happen given the assumption that there are an infinite amount of universes. But like well, doesn't that, I mean, it sounds ridiculous because like, like a chicken appearing out of nowhere. I mean, doesn't that disobey the laws of physics? I mean, I guess it sounds ridiculous.
It's like sort of like, okay, fine, let's do one that is. Like,
Okay.
of course you could find one that maybe, technically there may be a way that I could phase through that wall. Like,
Sure.
like quantum tunneling or something like
Well,
that.
if we just let's just stick to like known proven physics.
See, but how does that,
stuff
but how does that like sort of, disprove the argument in which that there are an infinite
Right.
amount of universes?
I understand what you're saying. You're saying what I'm assuming you guys are saying is like, so what? So what that something's so improbable that it basically can't exist. It has to be infinite. And, I guess I really don't have a good argument against it. Really, my belief is just based on the fact that, like, it feels like magic.
Sure.
And, whether the magic is real or not, I don't believe in that magic. We could argue about maybe whether, like, if it's, like, just because of how ridiculous it is, it still might be possible. But, and again, I keep going back to other examples, not necessarily to prove necessarily that, like multiverses maybe, I mean, I don't know, maybe it might exist.
Yeah.
But I'm trying to prove that everything else that seems like it's infinite, like, like the splitting up a particle until it's elementary particle or whatever, splitting up a block till it's elementary particle, finding a time, infinite time, talking about the paradoxes there. Every time you involve infinity into the real world, whether it's a perfect circle or any of my examples I gave, it just doesn't work. And so maybe we can use it mathematically, but I just don't see any possible way it could be used in the real world.
All right, so if we can agree that infinity is real in the mathematical world, why is it that we have a distinction of infinity between the mathematical world and the physical world? Why is it that infinity is allowed in the physical world, in the mathematical world, and it works, but in the physical world, we don't know yet, but let's assume that it doesn't work, okay? Why is it that infinity doesn't work in the physical world?
Fascinating question. I in my opinion, I think it would be like the inherent paradoxes it causes. This is for at least the real world why it doesn't work. And I think in mathematics, we find paradoxes in infinity a lot. Like even in the mathematical world, sometimes infinity doesn't work. For example, I don't know. There's a theory for the one where you showed me before.
Oh, would you like me to explain it?
Sure, go ahead.
Okay, so, well, before that, why don't we explain how infinity does work in mathematics first?
Limits. So I guess the the more important one is like something. If a number repeats itself forever, it can equal a fraction.
Right. So like 0.9999 equals 1.
Which is interesting,
right.
But it totally makes sense because you can't find a number between 0.9 repeating and 1, so therefore they are the same.
Mm-hmm.
But now...
But why don't we talk more about, like... Because before I explain the example in which infinity doesn't work in the mathematical world, I'm going to explain when it does work. So, calculus, integration, right? You're approximating the area under the curve, and you come up with, like, rectangles. You draw 2 rectangles, and then you reduce, or you increase to 3, 4, 5, and you increase the amount of rectangles to infinity, and at some point it converges to the actual area under the curve. So that's when infinity does work in mathematics. But let's think about this paradox where I don't know how, if I can actually explain this, but I'll try my best. So we have a square, right? And we have a square, and we're trying to calculate the length of the top side and the side, which would be 2 if it's a unit square, right? Because it's 1 plus 1. And if we reduce it to stair-like shape,
put a diagonal into it.
Right.
Sure.
Right.
Split it in half.
Split it in half diagonally.
Right. And then if we increase the amount of steps, then at some point it's going to look something like an equilateral right triangle, right? And theoretically, the length of the hypotenuse in a isosceles triangle should be square root of 2.
Right.
Right.
If each side
Right.
is 1,
Right.
then the side connecting them should
Right.
be.
But we get this paradox where it also has to equal 2. Because it was reduced from that square where two of the sides were actually
1 and 1,
yeah,
and
exactly.
now it equal 2.
Exactly. So that's when infinity doesn't work.
So
It doesn't quote unquote converge, right?
You know, you get like,
Yeah.
you know, square root 2 equals 2. And, you know, this happens a lot. You know, I've seen at least a couple proofs where it's like infinity doesn't work. You know, a lot of like, you know,
Yeah.
on YouTube math videos of like
Sure.
proving 1 equals 2 and just, you know, a lot of that's pretty silly, but it's an example where infinity just doesn't work. You know,
well, that's purely in mathematics. That's not even taking
Yeah,
it to the
right.
physical world. You know, which is very interesting. But maybe that's more of a flaw in our system of math rather than a intrinsic inconsistency within the universe.
So is it so you're saying it's the flaw where you're saying we have a flaw of how we understand mathematics instead of a flaw in mathematics itself, the system of mathematics itself.
Well, it depends on how we define mathematics, but I think with what you're saying, yes.
Because
Yes,
about the
it's-
square root of 2 equals 2 example, you know, it doesn't make sense. But is it that we're not understanding the problem, or is there actually some kind of a
Well,
flaw in
isn't it-
mathematics itself?
Isn't it more likely that we as humans, as fallible beings who can't, you know, who don't know everything for certain, have made a mistake in the way
Sure,
that we
that's more
understand-
likely. That's
Right.
more likely.
Right.
But I mean, mathematics isn't. It's not. It looks perfect, but I mean, there are flaws. Like,
Yeah.
there are things that don't
Well,
work.
Are you talking about mathematics as the system that humans use, or as just like the general like abstract idea of
representing the universe
Right.
using
right? You know,
using some sort of
are you talking about the absolute perfect system of mathematics, the way that things are,
Oh,
or the way that humans understand it, the way that humans use it?
I mean, what would be a perfect system of mathematics? You're saying it was if we had a different system, which I'm having a hard time understanding what a different system of mathematics would be. But assuming we did, maybe we counted in terms of like pi or something like that.
Yeah.
Pi equaled 1 or some different
Yeah,
sort
you
of
just use a different base.
or a different base. Yeah, like that's the only assumption I could think about. Like, would that problem work? Like, you're saying we have the exact same problem, but now we're switched up.
Well,
our,
I'm sure as a simple change like changing the base wouldn't
wouldn't
necessarily
solve the
do
problem.
much.
So then what sort of mathematical like I'm trying to think like
Well, I mean, you can ask anybody on Earth right now. You probably won't find an answer for like a different system of math that works perfect or that works better, which is kind of the point. You know, it's like we can't necessarily comprehend or think of or
yeah, I agree.
describe
Even
that.
if you had two different systems of mathematics, I don't necessarily think that problem could be solved. Like even like also like is there such thing as a perfect mathematical system that we could use?
Well, you could argue that system is used by whoever or whatever made everything, right? Because it does follow some series of laws, some it has like hard limits to it, you know?
that also is a great question. You're saying like, you know, whoever created this universe, or
Or,
you
I
know,
mean, it's
no,
that's
I
just an
understand,
idea,
I
but-
understand,
yeah.
I understand. It's the idea that like I guess we could, you know, if we're gonna talk
Regardless-
about it, like
regardless of creator or whatever.
right,
like,
but like
stuff has like
why, right?
right, yeah, like we are limited, you know, and things follow patterns, right? Which means, now I guess we have to talk about whether those patterns actually or those laws actually exist, or you know, is it just God? See, I don't know. Do those? I think the fact that everything sort of follows a pattern and that everything can be described and sort of predicted, at least we think so far, given our observations, that sort of means that there probably is a fundamental perfect system of something that describes and governs how reality works.
Well, let's think about why
Like that's
why we often think infinity isn't real in the physical world and why it kind of has to be. Because think about this: if we have an equilateral not equilateral, if we have an isosceles right triangle, so 1, 1, and then square root of 2 as its hypotenuse.
Yeah.
Well, in the mathematical world, it has to be that way by logic. Now let's think about having an isosceles right triangle in the physical world. So we're assuming that the two equal sides of that right triangle equal to 1, meaning its hypotenuse has to be irrational. It has to be infinite. If you have to measure it, and it has to be literally infinite. And is that even possible? Like, is that possible in the physical world? And I think it's because here's the thing: we're assuming that those two sides equal to 1, so that's the unit length. Now, compared to that unit length, we're assuming this hypotenuse is irrational, right?
Right.
Meaning its measurement has to be infinite.
Yeah.
Right.
Yeah.
Well, so does that make any,
It's kind of evidence for infinity existing, and well, I guess that's still in the mathematical world.
No, but I'm saying like in the physical world, it can't be. The measurement can't be infinite, right?
In the physical world, you would never have an exact.
Exactly. You can never have exactly one unit.
Okay, let's say it was varied slightly. Like this is 0.987 blah 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 blah, and this is 0.99 blah 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 blah.
Okay, but it doesn't matter if it's
the side is still irrational.
no, but okay. So what I'm saying is, don't focus on the numbers. It doesn't matter if it's 0.97. We can assume that as 1. We can make that the base unit. So we can assume that as 1
in the physical
something.
world, we can't assume that as 1 because there's nothing that is just.
No, but that's the unit length. We're making up another unit. So we're assuming that is 1.
If we take this thing
and that is 1.
So audio
Exactly.
only listeners, I'm
Right.
just holding up like a random ruler thing.
No, yeah.
And yes, I know that this ruler is not exactly 1 foot, but what if we just defined this as
we're assuming
one
that as
ruler?
1.
The unit is ruler, and it's all based on this ruler.
Exactly. And
Okay.
even if you were to do that and construct an isosceles right triangle, its hypotenuse would be infinite. So its measurement has to be never ending.
Right. Which means that's infinity existing before our eyes. Or is that an infinity existing, or like are these measurements sort of like just arbitrary and don't really mean that they exist? Does the measurement of something exist? Because obviously this exists, but does the exact measurement of how long it is from start to end, does that exist in reality, or is it just literally the physical object that exists?
Like, does the measurement exist?
Yeah, does the measurement exist?
That's a great question.
Well, see, I don't know about the measurement, but the ratio has to.
But why?
Well, because how do you measure things? Like, what does it mean to have like let's say this is 1 foot. I mean, that doesn't mean anything. We made up the units, right?
Sure.
So what makes math effective? Like why do I think pi exists? I think pi exists because every circle is similar, just like every equilateral triangle and every isosceles right triangle are similar, right? So in that way,
circle, you can't have a circle in the physical world, can you?
no. But does that mean pi doesn't exist?
In the physical world, yeah.
Well, okay, but I'm saying like in reality, overall, both physical and mathematical.
I think
No, yeah.
we're sort of. I don't think I'm saying that pi doesn't exist in the real world. It's just the pi in the mathematical world repeats forever. It's infinite, and the pi in the real world
Doesn't.
at some point will end.
Right.
I guess that's more what I'm saying.
But then also, doesn't the measurement of this, whatever, this ruler, which isn't exactly a foot, it's something that's really close to a foot, right? Some measurement that's really close to a foot. Does that measurement exist? Because if so, then that's irrational and infinite, just like pi.
Like the measurement itself.
Yeah. Yeah.
What do you mean?
Well, see, I'm holding a ruler, but this isn't exactly 1 foot, right?
Sure.
It's got like, some really small little bit left over, or some little.
No,
really
I'm
small
sure it
bit
ends.
that's
It ends though. Like if you're okay, I'm assuming, are you measuring it in centimeters? Like I don't think I'm like, let's say we're to measure that
You
exact.
can measure
ruler.
it in whatever you
Yeah,
want.
yeah, like inches, centimeters. Like let's do inches, right? And it's a little bigger.
Yeah.
Okay, I mean clearly it is. But if we were to do that, then at some point it would have an ending spot. It would not go on forever.
See,
Are
I
you
don't.
sure?
I don't.
Yes, I'm. Oh, I believe it is. I mean, if it see, now you're getting other points, but like I would think this has an ending spot. Just like you can have a perfect circle, like that would go on forever. This exact ruler has an amount in inches that's like defined. Like
So
it-
if we
looking-
I guess if we measured this in planks,
Planck's constant.
yeah, there would be a defined number of.
Some very, very large number that's
Sure.
discrete.
that's discrete. That's defined.
That's true. That's true. Yeah.
All right. Okay, why don't we talk more about like the kind of the essence of infinity? So I'll give you an example. So you guys ever thought about like how infinity is? I don't know how to describe this. Similar to negative infinity.
Sure.
Well, think about this. Like, what's the slope? All right. So since we're recording a video, I think we can show this.
Okay.
So what's the slope of here? You guys, why don't I show you like this so you can just watch that screen?
Yeah.
All right. So what's the slope of this? It's approximately 1, right? Because it's around 45 degrees with the horizontal.
Sure. Yeah.
So then what's the slope of this? It's
Bigger
some
than 1.
some higher positive number.
Yeah.
Right? Then what's the slope of this?
Bigger than one.
Right. So then what's the slope of this when it's vertical?
Infinite.
Or is it negative infinite? Because what's the slope of this then? It's -1, right?
Mm-hmm.
But as you approach, or as it becomes more vertical and vertical, it approaches negative infinity.
Mm-hmm.
So it's approaching negative infinity and infinity at the same time. It's just like
Well,
when you graph 1 over x and you try to find the limit when it approaches 0, it approaches
Sure.
infinity from the right and negative infinity from the left.
Well, but this is a little different, like you definitely, like you can only choose to go from left to right or right to left. So it can only be infinity or negative infinity. Right?
No, and also, how is this different than -1 and 1? Like you're like they both look the same. I mean,
No, I'm saying because, well, this is like a visual representation of 1 in terms of slope, right?
Right.
This would be -1. But when it's exactly vertical, it's both infinity and negative infinity at the same time.
but okay, I'm imagining like a. Like
No,
a-
actually, no, I get it.
I'm thinking of like an. Well.
So does
I
that?
think I
I
see
mean,
what you mean.
see,
Oh, you're saying the line itself, like negative infinity, the line is like a straight up vertical line.
Mhm.
Negative infinity, the line is straight up.
exactly. So they're the
vertical
same.
line.
So they're the same.
Yeah.
So what does that tell us? I mean, what does that mean? Or why don't I just give you another example, okay?
Okay.
How many sides does how many sides does a triangle have?
3,
3,
Rectangle,
4.
4.
right? Now okay, how many sides does a circle have? Is it 0
Infinite or 0?
So-
that's
Or
a.
it could be 1
How could it be 1?
because it's one line.
No, but then it has to be straight. Like
Yeah, no,
it
that
has
doesn't-
right. So it has to
Okay.
be
But how's that similar to? Is it negative infinity sides? That doesn't make sense.
okay. So what I'm trying to point out is we get a little things get a little weird when it goes to infinity. No, like we can't tell. Does a circle have 0 or infinity sides? And I mean, in
I would
some
make the case for 1. I'm just being honest.
See,
One.
Yeah,
okay, but
how does it have one side?
'Cause it's one line. You can.
But
No, but then it's not straight.
That's for
no
straight
edge.
It's
lines.
not straight.
That's for
line
straight
with
lines.
no edge. But I mean, obviously it depends on how you define a line, but you know,
that is how you define a line.
A square has 4 lines because you go down and then there's an edge, then you change your angle, right? And then there's a different edge, you change it again. But a circle, you never meet an edge until you get back to the first point. Right? I don't know.
That's interesting, but I mean, even if that was true, that's still very interesting. How they all kind of collapse at one point.
You know what's fascinating? I remember when I was younger, like very young, elementary school, we were talking about infinity, and everybody said 1, and I learned to count the.
What do you mean? Everybody
like
said,
they asked the kids how many sides it had, and most people said it had 1.
A circle?
A circle.
Oh, great! So I have the intelligence of a.
I remember. My system was wrong. The way I count sides is by counting corners. That was the way I was taught, which is so silly. But I remember thinking, there's no corners on this. So how could it have 1 side?
Well, then you have to say, you know, is the starting point, does the starting point count as a corner or an edge? You know? No?
It doesn't count as a corner.
Okay.
Yeah, but isn't it interesting how, like...
Then it has 0 or infinite.
Yeah. Because think about, like, 0 and infinity. I mean, they should be the exact opposite.
But yeah,
just by our intuition, like 0 and infinity seem like they should be the exact opposite. But when it comes to the question of how many sides does a circle have, it's like both 0 and infinity at the same time.
I would say it's infinity. I would make the case for infinity. You know, this is a theory that or an idea that many people have shown, which is you take a triangle and you take a square and you imagine adding more and more sides to this shape.
Right. So it approaches infinity.
It looks
so some calculus thing.
Yes, it looks to be a circle.
But I don't think it's also kind of rational to say that it has 0 sides.
Yeah.
You know?
Yeah. But really, it's all based on definition. You know, I feel like once you define things, isn't there a clear answer? You know, give me a definition of what you think a side is.
That is a great question because there's no what's 2-sided? What has 2 sides? You know,
like a shape or like a polygon with 2 sides.
Give me a shape maybe with 2 sides.
I mean, an L.
Yes, and then 1 side,
just a line.
Just a line, maybe.
Yeah.
I mean,
so
maybe how did you know, and you think about it as a line, right? 1 side is a line. If you look at the pattern from 1 to infinity, it obviously makes more of a circle, right? You have a line, then an L, then a triangle, and it just keeps building itself to a circle. But it just goes from a line to just a circle to 0. I would think 0 sides literally just means nothing. There is no line, 2 lines, 3 lines, right? Maybe for the camera, right? Line, 2 line, 3 line, but for a something with 0 sides, there would just be nothing. Nothing can have 0 sides. That's, I mean, I don't know if that's right, but you know.
What if we changed your idea of what a side is? Then we could find something that would make you say infinity. You know, you could just. It's all based on definition. I feel like this question, isn't it? But you do bring up a good point. Is our intuition can see. Or at least, maybe not in Ben's case, but I can see it being 0 or infinity,
or even 1.
Yeah, or 1.
Or 1.
There's multiple intuitive answers, but the correct answer only depends on
opinion, or is there a correct answer?
Well, the opinion would be based on the definition of the question. So I feel like there is an objective answer, just depending on what you define as a side, what you define as a circle. Stuff like that.
You guys know there are different types of infinity?
Yeah.
Oh, I love this.
This is a very curious topic.
I love this. This is so cool.
Tell us, Luke.
So, when it comes to infinity, you have to remember that you can't use your intuition. You might think that the number of natural numbers is greater than the number of even numbers because even numbers just the quote unquote half the size of natural numbers, but that's not true. The number of even numbers actually equal the number of natural numbers.
If we wrote out all of the natural numbers we have 1,
2, 3, 4, 5. You can connect them with 2, 4, 8, 4, 6, 8.
this goes on to infinity.
Right.
So if you try to connect
Exactly. You can match them all.
1 and 2, 2 and 4, you keep going.
Right.
Whatever.
Every
single
number
digit will have
would
a
have
corresponding.
Right.
a match, and that is a fundamental theory to math.
Yeah.
A correspondence 1-to-1 would therefore mean they have the same amount.
But let me ask you this. How many real numbers are there?
Real numbers include irrational numbers, so 0.000,
Right.
repeating to 1.
You can't match them all. So the number of real numbers is actually greater than the number of
Proof
natural
of this
numbers.
is pretty difficult to understand, but I guess the best way to do it is because you would think you could do the same thing with the rational number, just set
Sure.
1 to equal 0.00001 and just continue
But
up.
then what's
Right.
0.00000, like it's
Yeah, what's
you
the
can't-
s-
you
what's
can't-
the
you
s-
can't, where do you start?
Right. What's the smallest non-zero positive number?
It's just
But
yeah.
you think it's infinite. You think 1 to infinity, so it's infinite. There's infinite amount of numbers, and there's infinite amounts of 0.0001s. I think the best prove this is if you have a list of numbers, right? Imagine 0.00001 point. Imagine you have like. I think the best way to think of it is like 0.00001, 0.111111, 0.22222, and or maybe like and then change the last number at the end or something like that.
Mhm. Yeah,
you could have a number
That was never in
that
the
was
set.
never in the list of sets,
Exactly.
basically. So it's weird how there's like different levels of infinity, which doesn't even make sense
because infinity is just infinity, right?
yeah, and I find that
Yeah,
fascinating.
that is really fascinating.
There's another one. Do you guys want to give another example another good example to understand different types of infinity? I think that would be kind of cool. It would be like if you had imagine, right? Me and Devin were like in a line, and or like in like an open space, and there was this infinite line of billiard balls. And we both had our own line of billiard balls lined 1 to infinity.
Yeah.
All right? And we each had our own hats. So I had my hat, he had his hat. He had his line of infinite billiard balls, and I had my line of infinite billiard balls.
Yeah.
And I said, I'm going to take the first 10, and I'm going to put that number 1, the first ball labeled number 1. They're all labeled, right?
Yeah.
I would take the number 1 and throw it away. So I put all the rest of the 9 into the hat, and the 1 I'd throw it away. Devin would do the exact same thing. He would take 10 balls, put them all in his hat, but instead of taking number 1 away, he would take number 10 away, ball number 10 away. And we continue this process. So now I grab balls 11 through 20, and I take out number 2. He does the same thing, grabs 11 through 20, and grabs balls 11 through 20 on his own line, and grabs number 20, right? And we continue this on forever. We know which balls Devin did not pick out. We know he didn't pick out number 2 because he picked out 1, 10, 20, 30, whatever, right? I, on the other hand, what balls did I not pick out? And this is a fascinating question because if I were to say if I were to do this like 5 times, right? So all the way to ball number 50, and I take out ball number 1, 2, 3, 4, and 5, right? Yeah. This makes sense. Like each time we're adding more balls to the hat because even though I'm throwing 1 away, we're adding 10 balls more.
Yeah.
Yet, so it seems like there's more balls being added to the hat. Yet if we're doing it an infinite amount of times, technically I grabbed all the balls and threw them out of the hat.
It's true.
Which is wild. Even though
I would have infinite balls.
And you would have infinite
You would have
balls.
none.
I would have
I would
none. Even though we did the exact same thing, but you grabbed ball number 10 and then ball number 20, 10x, and I grabbed ball number 1 through infinity. Exact same thing, totally different results. Infinity does not exist in the real world. Proof right there.
I think it's interesting how we're assuming that infinity does exist in the mathematical world, which I agree. Yeah. But then that begs the question of, okay, so then why does infinity exist in the mathematical world? What makes it possible?
Oh, is it human intuition? Because when I first learned about limits, it made a lot of sense. even though it makes no sense in the real world, my argument, of course. Like you think about it, like when you're learning about like the integration area under the curve, right?
Yeah.
If you have we already talked about this. If you're measuring the area under the curve and you measure in infinite amounts of rectangles, it makes sense. It's again the arrow paradox. It makes sense. You're splitting an object in half and half and half and half and half, and once you do that, it fills up all the area, at least in integration, and it's intuitive, but. I don't know. It's such an interesting thing to think
but
about.
not real.
Yes. Intuitive, but not real, which is just mind-blowing, at least.
Well, maybe that speaks to what math is. Math is just a tool to help us understand how reality works, but it can't necessarily function same as reality. Like we can't have math in the real world perfectly, like it exists on its own. But infinity is just one very, very essential part of math that helps us really understand reality. It's very. I mean, math is intuitive. It's like a lot of. I don't know if I can necessarily speak for animals, but I feel like, at least a lot of living beings know how to count or use some sort of, very basic system of math to function, which means that math is intuitive. I mean, definitely humans use it, which means math is intuitive to humans.
I think
Right.
it's amazing how our minds are even capable of sort of imagining infinity in the first place. That's fascinating to me.
For sure. Like, okay, you're implying that, like, we really can understand what infinity is, though. I mean, can you, though?
I mean, we have a bunch of... Now, I'm not saying we perfectly understand it, but we kind of have an idea of what it is. And I'm saying, like, it's possible... Like, it's amazing how we have this level of consciousness where we can actually understand such concepts like infinity. And how humans have discovered the fact that there are different types of infinity, which is really against our intuition.
Well, do you think that other life forms can imagine infinity? And do infinity and zero come in a package? Can you? Because I feel like if you understand what zero means, then you also have to understand what infinity means.
Interesting.
I feel like they're total opposites.
Well, that's the point.
That's the point?
Yeah.
Okay.
I mean, we kind of like. I mean, it's very common for us to define things by their opposite, right?
Right.
So.
Everything versus nothing. That's wild.
That is wild.
Understanding what everything is just doesn't make sense, though. Like, I like even thinking about, like, infinite amounts of phones. Like, that would mean that, like, you could fill the whole universe, but then that's not even close to what infinity actually is. Like, the power of what it implies is just kind of crazy to me. It's so weird and foreign for our brains to understand it, that, like, having me on this podcast, like, my argument is it's so weird and so foreign that it literally cannot exist. And I don't know.
I don't know. Maybe it's like, infinity is sort of intrinsically, it's very easy to understand, but when you consciously, it's very hard to understand.
That's true.
That's a little bit of a paradox,
What
would
an infinite universe mean?
Whoa, infinite universe. I think we talked about a little bit. What do you mean in infinite? Like infinite time, infinite space?
Yeah, so if time was infinite and everything will happen, what would that mean?
That's crazy to me. That's a good question.
Well, see, if time was infinite,
then everything has to happen as long as it doesn't obey the laws of physics.
I don't know if that's necessarily true. Just given the constraints of our reality, because what about the decay of matter? So even if time went on forever,
no. But if we're literally talking about infinity, if time was literally infinite, then everything has to happen as long as it doesn't disobey the laws of physics.
Right, but that's what I'm saying. Like there's stuff that could happen that won't because of how physics or chemistry or whatever works.
Right. So everything that could happen obeys the laws of physics, then it will
sure,
happen.
Sure. But just to be clear, it's not like, it's not like everything that's possible to happen in the universe will happen. It's just everything that...
Yes, it will. Yes, it will.
No, okay, but
that implies
okay, so
infinite.
it's, if we say that this universe started with a Big Bang, something like that. Okay, there's a finite amount of matter in the universe, right? And like over time, like elements have half-lives and whatever, and so they decay into different elements, and so eventually, with infinite time, the same resources that were once available won't be available anymore, right? Which means the things that were once possible can no longer be possible.
But it could happen again. It could emerge again.
Well,
How would
that's
that
an
happen?
assumption. That's a big assumption, right?
Well, given the fact...
Hold on. You're saying decay of matter. Isn't, like, energy always conserved or something?
Yeah, energy,
like that?
but not matter. I mean, well, matter changes.
But
Like-
it could
like,
appear again. Why not?
Sure, but that's what I'm saying. Like, that's an assumption,
And I think that's a reasonable assumption, given the fact that time is infinite. It's infinite. It's not just really long. It's infinite.
Wouldn't that also mean the expansion of space would be infinite, which means, you can't really coalesce those particles back together to create or reform those whatever that
now we're getting
happened
into
before.
different discussion, because have you heard of the Big Rip before?
The Big Rip?
The Big Rip? You've never heard of that?
Well, that sounds like a massive fart.
It's a theory that eventually the universe is going to rapidly decompress, like expand, and then
Yeah, I have heard of that.
The infinite
Yeah.
like Big Bangs type theory.
Yeah.
Well, it could be possible.
Well, if we change our assumption to let's say the big fart is happening, then which I think is what is more helpful, for this thought experiment. Everything that can happen will happen.
Have you heard of maybe I think it involves Schrodinger's cat or whatever.
Okay.
Which is the idea that like matter can form inside of something that, like, if you have a box that's nothing, like a vacuum, nothing, only has space.
Yeah.
Which whenever we talk about time, we have to talk about space. Assuming time's infinite, space has to be infinite. All right, let's get that cleared out. If we have a box, right?
Yeah.
There's like a like quantum proof or something that like
Quantum vacuum stuff?
Yeah, that like some particle could just spawn inside there. Like there's like it's like we were talking. Remember when I was talking about like quantum tunneling? Like if I walk through this wall,
Yeah.
right? And
Or
I talked about like
the chicken will appear.
the
Yeah.
chicken, right?
Yeah.
I think the chicken. There is technically a scientific proof that will prove a chicken will appear in my hand. Like a particle can technically on the very micro level spawn.
Yeah.
Out of nowhere, just completely nowhere, and I think they proved it using like I don't know, maybe a vacuum or something like that. Like they were able to prove it. It involves something with quantum and quantum mechanics and more just like, and if we assume that anything can spawn anywhere, now technically, the proof is that if you have infinite time and infinite universes, then technically this entire world, like this entire, like, not entire world, yes, entire world, like Earth, could technically be recreated.
Yeah.
And technically, like,
solar system too.
a whole solar system, and me and you could be exact clones. Like, we could spawn again, billions of years in the future, trillions. And again, it's infinite.
Sure.
Once again, back to the original point, back to square one, you start to realize things become magic. Things become magic when you reach infinity. And that will be the lasting argument that I hope to explain on this podcast.
What?
See, I agree, but...
What are you thinking?
Well, see, I understand what you're trying to say, but... It's like reasonable, but also unreasonable, you know?
You know what we should really talk about is the sort of do paradoxes exist in reality?
Ooh.
You know, like can
Yeah, we should do that for our next episode for sure.
we'll have you back, Ben, to talk about that. But yeah, I mean, there's paradoxes everywhere in math,
Uh-huh.
you know, or logic even. So,
Huh.
you know, it kind of makes sense that they would exist in reality, but then it also doesn't, which is a paradox itself.
That's for next episode.
Next episode.
Thank you guys so much for having me on the
Yeah.
show.
Yeah, of course.
Thanks for
You
coming
were
on.
great. You were a
Appreciate
great
it.
guest, Ben.
Hopefully, for the audience listening, made it this far.
Yeah.
Congratulations. Thank you for
Yeah.
making it this far. I hope maybe your ideas on infinity and how it, applies to the real world versus the mathematical world has been enlightened and your opinions have been changed, hopefully. But
Or at least you thought about
or
it.
at least you thought about it.
Yeah.
That's right.
Yeah.
For sure. Thanks for coming on.
Yeah, thanks, Ben.
Appreciate it.